Hello. So this segment we are going to be converting absolute values into piecewise functions. So how do we do that? Well, remember the whole idea, right, is that we want to be able to capture when the absolute value is sort of changing, right? Because the whole thing is that if it's positive inside, nothing's happening. But if it's negative, then we have to make it positive. And to do that, we have to do the whole, multiply by -1 bit. And so we have to figure out where that point is. So we can start by taking the part that's just in the absolute value, right? Just the part that's inside. So we have that negative 3x minus 2. And we want to know, when is this thing greater than or equal to 0, right? Because the idea here is we want to know, when is the absolute value doing nothing versus when is it doing something. Now, to be fair, the greater than or equal to, right, the equal to part I can actually put on either part, because if it's equal to 0, it's neither positive nor negative, so it doesn't really matter. So I'm going to do greater than or equal this time. Maybe in another one of these examples, I'll do it so it's just strictly greater than, and the equal to will go on the other part. And we'll see how that sort of filters down in the piecewise version. So if I'm solving this, right, I can either move the 3x over or the -2 over. I'm going to actually move the 3x over, because then I'm not going to have to divide by a negative, and that'll make me, I don't have to remember to flip the sign or whatever. So I'm going to have -2 greater than or equal to 3x, and then move the 3 over. So I'm going to get -2/3 greater than or equal to x. Okay. So this gives me the point that I need. In particular, right, I have the -2/3. So this is where my piecewise function is going to have that pivot point, that part where I'm going to sort of change from one function to another, transition point, whatever you want to call it. So here, if my sort of original function is this function up here, right, the absolute value, -3x minus 2 plus 6, I want this to equal, I'm going to have some piecewise function where this is going to be sort of the part where I need to care for the off to the side bit, right? So I'm going to have a section where I have x is less than -2/3. So I'm going to have, again, just for the sake of making it sort of look nice, I'm going to flip it around a little. So I'm going to have x less than or equal to -2/3, right? Because I'm just flipping these around. So, because I don't know, I'm crazy. I just like the way this looks. But for that section, that means that the -3x minus 2 is positive, right, or not negative, which means the absolute values do nothing. So in particular, I can just replace these with parentheses. I'm going to have -3x minus 2 plus 6, right? And then I have the other case, right, where, so this is where an x is less than or equal to -2/3, but I have the other case where it's on the other side, right? It's greater than. So I have the case where -2/3 is less than x, or x is greater than -2/3. For reasons that aren't particularly important for this class, but most mathematicians like the less than symbol more than the greater than symbol. I realize it doesn't really matter, but it's instinct to me at this point. So that's why I'm doing that. But you don't have to do that as long as you write the right thing, it's okay. So when x is bigger than -2/3, that's telling me that this thing, right, this -3x minus 2, is not greater than or equal to 0, meaning that it's negative. So now I can replace it with parentheses, but I have to be careful because I'm going to have the negative, right? I have to make it negative by multiplying by that -1. And now I can simplify, right? So for the top, well, these don't do anything because they didn't get multiplied by -1, so I'm just going to have -3x minus 2 plus 6, so I can put those together. I'm going to get -3x plus 4, and that's when x is less than or equal to -2/3. And down here, I'm going to have the negative, but I have to distribute it, right? So I have to be careful, because this is really a -1, so I'm going to multiply it against both things. So that means that the -3x times -1 becomes +3x, and the negative times -2 becomes +2. +2 plus 6 is 8, so this becomes +8. And this is when x is greater than -2/3. Okay. And that's that. So all we got to do is, right, just as a quick recap, we have to figure out when is this thing greater than or equal to 0. So I move the 3x over and then divided by 3, and I get whenever x is less than negative 2/3, right? That's when nothing happens. So that means if nothing happens, it just stays as is. I get negative 3x minus 2. I can replace the absolute value with parentheses. I still have that plus 6, can't forget that. That's when, right, x is less than or equal to negative 2/3. On the other hand, when x is greater than negative 2/3, well, now I have to multiply by negative 1, right? Because if x is, to be clear, if x is greater than negative 2/3, right, I'm in the opposite situation, right? So before, when it was less than or equal to negative 2/3, that's when everything was positive inside or not negative. So if it's greater than negative 2/3, that means the inside is negative. That's why I have to multiply by that negative 1, right? But then I have to distribute that, right? So the negative and negative cancel. I get positive 3x. The negative and the negative 2 cancel. I get, well, positive 2 plus 6 is 8. Up here, everything stayed as is, so I get negative 3x minus 2 plus 6 is 4. And of course, where that sort of applies, right? So that is that. Hello. So in this segment, we are converting absolute values into piecewise expressions. So as usual, right, we want to start by knowing when is the part that's in the absolute value, when is that thing not negative. So we have to sort of copy that part, right? We want to take the part that's in the absolute value. So we're looking at, let's see, 2x squared minus 4x minus 6. And we want to know when is that greater than or equal to 0. Now, unfortunately for us, we can't just solve this thing directly, right? I can't like move the 6 over and divide by 2 or something like this, right? So this is a quadratic, which means I'm going to have to factor this thing. Now, I can start by factoring out any common terms. And in fact, here I can see everything is divisible by 2. So I can pull the 2 out. Now, strictly speaking, since all I'm after is this positive negative bit, I could just divide by that 2 and get rid of it. I don't sort of want to be in that habit just because sometimes dividing by that 2 matters, sometimes it doesn't, depending on the exact sort of what you're trying to accomplish. Here, it turns out, it doesn't matter because all I want is positive negative, but unless I see some other reason to do it, I'm just not gonna. So I'm going to factor this part next, and the reason I'm doing that is because I'm trying to set up a sign chart, right? Because this whole idea of like, oh, it has to be, right, greater than or equal to 0, what I'm really thinking is, where is it positive, where is it negative? So easiest way to figure that out, sign chart. So I'm going to take this, I'm going to factor it, which again, so like this is, right, minus 3, so I want two things that multiply to minus 3, add to negative 2. 3 is prime, so I'm looking at 1 and 3 of some form, right? So clearly I want the bigger thing negative, so I'm going to have 2 times x minus 3 and x plus 1. And again, if I'm not sure, right, I can always expand this out, right, do distribution or whatever you want to, sort of technique you want to use to distribute it out, because that should definitely get back to this thing, right? So I can always double check my work if I'm not sure. So now I've captured where is this thing sort of positive, but I don't actually know the answer. Like I've done all the work. Now I just need to do the sign chart, right? So in particular, I'm going to write down my number line. And I'm going to put on this number line all of the zeros and discontinuities. There's no discontinuities because this thing's a polynomial. So really all I need is the zeros, right, when each of these factors is 0. 2 is never 0. That's comforting, I suppose, right? But x minus 3, so that's going to be 0 at 3. So I'm going to need 1 at 3. I'm going to need a spot at 3. And x plus 1, that's going to be 0 at negative 1, right? Again, if I'm not sure, I can always write these things down. So I can say, okay, I want x minus 3 equal to 0, and then solve by moving the 3 over and get, that means that x is 3. Likewise, x plus 1 equals 0, which tells me x is negative 1 by moving the negative 1 over, right? So like I can do the algebra if I'm not sure, and sometimes that's very helpful because sometimes these are really gnarly factors, right? If they're sort of really bad. Here, we could probably just look at it and be like, what minus 3 is 0? 3, easy enough. So here I'm going to use a -1. Again, just to be real clear, if you, for whatever reason, put more sort of points on this number line than you should, it won't lead you to a wrong answer. It'll just increase the amount of work you have to do to get to the right answer. So it's sort of no harm done in the sense that, it won't lead you down a wrong path, but it does make you take longer. You have to do more work, and that's never fun. In particular, I want to note that I'm not putting 0 on here because that's sort of a very instinctual thing when you're writing an x-axis like this, is you want to be like, okay, the center is 0, and then I'm going to place points. I didn't need 0 because 0 wasn't a 0 of the thing, right? So I only put the -1 and 3 there. Now, I want to test, in fact, yeah, I can do it this. I want to test points to see, okay, which of these regions, like these regions are either all positive or all negative, and that's helpful because that means that I can test individual points, right? So if I'm like, okay, I want to know, is the, like between -1 and 3, is that positive or is that negative, right? I might have misspoke, but all these regions are either positive or all of the region is negative, so I can test a point. So here, right, between -1 and 3, I could pick a number. Any number between those would work. I could use e if I wanted to. I could use pi/2 if I wanted to, except I'd be crazy to do that, right? Because that's like, why would you pick that number, right? Like, why pick √3 when you could pick, say, 0? 0's between those. 0's easy to compute. Why not go with 0? So picking 0, I look at it and I'm like, okay, 2, always positive. I'm good with that. Putting in 0 into x minus 3, well, 0 minus 3 is -3. I don't even need to compute the value. I just need to know 0 minus 3 is negative. So I'm going to have positive, negative, 0 plus 1, positive. So I'm going to have a positive times a negative times a positive. That's negative, right? So that in-between region, negative. Now, I need to know, okay, what about to the left of -1 and to the right of 3? So I could pick to the left of -1. Now, one thing I could choose, right, is I could choose, say, -2. And in this case, that wouldn't be terrible because these numbers are kind of nice. But if I had some, again, gnarly thing in here, like the square root of 3 times x plus 17/4 or something, right? Like computing that when I have to plug in a concrete value, and then I'm like, all right, what is like 2 times the square root of 3? That's some annoying number that I have to like, it's like 3.4 something, right? You don't want to go down that sort of rabbit hole. Since I can pick any number to the left of -1, just pick some gigantic number. And again, the point is specifically not to compute, but to just sort of use your obvious intuition and be like, what happens if I have a giant negative number and then I subtract 3? It's negative. The 3 is not doing anything. If anything, it's pushing it more negative, right? So if I pick like -1,000,000, -1,000,000 minus 3, definitely still negative. -1,000,000 plus 1, definitely still negative, right? -1,000,000 times the square root of 3 plus 17/4. The 17/4 is doing nothing. Square root of 3 is some positive thing times a negative. You have a giant negative thing plus some small positive thing that does nothing. That's definitely negative. Like, this is the idea. You don't actually want to like compute it out because that defeats the purpose. The whole purpose is to avoid the computation. So a little bit of a tirade there, but so picking a large negative, obviously negative. 2 is still positive, really. The 2 never does anything. So I get negative times negative is positive. Likewise, if I pick some giant positive thing like 1,000,000, subtracting 3 does nothing, adding 1 does nothing, right? Those are still going to be positive. Positive and positive give me positive. So in particular, the thing that's inside the square root, inside the absolute value, so remember that's where all of this magic came from, that thing is positive when I am to the left of -1 and to the right of 3, okay? So now we can set up our absolute value converted to piecewise. That's the goal, right? So we have our absolute value, which I'm just going to copy down. So I have absolute value of 2x squared minus 4x minus 6. Then I have minus 3x and plus 1, right? So that was the whole thing. And I want to convert this into some piecewise bit. And importantly, what this showed me is that I have 3 regions, right? Because I have So left of -1, I have between -1 and 3, and I have the right of +3, where the sign is changing. And with piecewise, we like to have them sort of go in order. So even though I should get the same thing in this region and this region, I'm still going to list them separately because I want to have them sort of connected regions going down. So in particular, right, this region here, I can think of as x being less than or equal to -1. Here, I have -1 less than x less than 3. And here I have 3 less than or equal to x. So these are my three regions. So that's what's going to go sort of all the way to the right over here. I'm going to have x less than or equal to -1, x between -1. In fact, I'm going to, again, this is sort of a math person being way too particular because it really doesn't matter. So I'm going to do this. Doesn't matter like how I align these things as long as they are to the right and in the same row. And then I have that 30 is less than or equal to x. Okay? And again, because these are both positive regions, these lines should ultimately end up being the same, right? The top and the bottom should be the same. The middle one should be different. But I like and sort of need, when I have piecewise, I like to have it so that it sort of transitions between the spots, right? Because I'm going from this to this to this when I go from here to here to here, right? That's the idea. All right, so going back to my sign chart, I know this first part is positive. So that means that I can take this and just replace the absolute value with parentheses. Nothing happens, right? So I have 2x squared minus 4x minus 6, right? And again, because it's positive, those just get replaced with parentheses, nothing else, minus 3x plus 1. The bottom is going to have the same thing, right? So I'm going to get, again, parentheses 2x squared minus 4x minus 6 minus 3x plus 1. And again, to be real clear, this isn't because the top and bottom are always the same. It's because these are both positive regions, right? So positive means I just replace it with parentheses, same deal there. But in the middle, it's negative. So that means I still replace it with parentheses. So I'm still going to have the same looking thing initially, sort of almost the same. But because it's negative, I have to make it positive. So that means that I need to multiply by -1, right? I put a negative out front. And then I get the minus 3x plus 1. So I've sort of converted, I've done the hard step of converting to a piecewise, but I should still, right, I should clean this up, right? So I should make this sort of a nice thing. So here, this is all, right, the parentheses aren't doing anything, so I can just remove them and I can combine like terms. So I'm going to get the 2x squared minus 4x minus 3x is minus 7x. Minus 6 plus 1 is minus 5. Here, the negative, right, will distribute. So it switches all of these signs. So here I'm going to get negative 2x squared. Here I'm going to get positive 4x minus 3x. So I'm going to get a, right, this will be a, again, to be real clear, I'm just going to write underneath, this is going to become 2x squared plus 4x plus 6. So the plus 4x and minus 3x is going to be plus x. And then the plus 6 plus 1 is going to be a plus 7. And the bottom, same deal, right? The parentheses do nothing, so I can just remove them and combine like terms. So I'm going to get 2x squared minus 4x minus 3x is minus 7x. Minus 5 plus 1, minus 5. Sorry, minus 6 plus 1 is minus 5. And then don't forget, we want our, right, the domain part. So this is going to be for x less than or equal to -1. This is going to be for -1 less than or equal to x. Sorry, less than x. Although I'm going to make a comment about that in a second. This doesn't erase well, so I'm just going to erase it all. There we go. negative 1 less than x less than 3, and 3 less than or equal to x. Okay, and so this is the final version, right? This is the piecewise function that this thing translated into, that I sort of got to. Now I want to make a comment because often sort of the way this comes up, it is usually demonstrated that like I want, okay, this thing only does stuff when it's negative, so I'm going to find where it's not negative, which is the greater than or equal. But there's no reason why I can't think of 0 as sort of being the flip, meaning like I can say, okay, this thing doesn't do anything when it's already positive, right? In which case I would have had just greater than there instead of greater than or equal. And that would have sort of propagated down the whole way, right? So I would have had that each way. And what would eventually happen is that these would have changed so that that would be less than versus less than or equal versus less than, meaning like where the equals would have changed, which would have ultimately changed these so that you would have had things like x less than negative 1 less than or equal to x less than or equal to 3, and 3 less than x. And it turns out that this is actually the same thing. And the reason it's the same thing is because if I actually plug in, say, negative 1 into either of these, if I've done my math right, then I should get the same answer. I won't necessarily get 0 because the 0 occurs from here, right? If I plug negative 1 here, I will get 0 in both cases. If I plug 3 into here, the absolute value part, I'll get 0 in both cases. So this part won't be 0, right? So I'll get some other number. I won't get 0 for the whole thing. So this whole thing won't be 0. But these things will be the same value at negative 1 and 3. Same with these things. And what that tells me is that where I put the equal sign isn't important. So I can move the equal sign between any of these, and that would be fine. For convention and a number of very good reasons, you don't want to have equal signs overlap. So like if this one has the equal sign, that one shouldn't, because I only want negative 1 to land in one of these places, right? Same here. If this is the equal sign, that one shouldn't be. Or if this is the equal sign, then this one shouldn't be, because I only want it in one of those two places. But where that equal sign lands, that's really up to you. It doesn't actually make a difference because of the fact that these things equal the same numbers at both of those numbers, which ultimately comes from 0 is neither positive or negative. So to be very clear, you could do it whichever way you want. Pick your favorite, do it that way. Just know that like if you're looking at some sort of situation where it's like which of the following are equivalent and it's all the same except the equal signs aren't quite in the right place, that's probably what happened, is that they got sort of solved in a different way. And so that's why you got the equal sign at a different spot, but it's still the same thing. Okay. So that is that. Hello. So this segment, we are going to be converting absolute values into piecewise definitions. So to start, we're going to take our nice little absolute value here, right? So like just the part that's in the absolute value. We want to know when is that positive, when is that negative, so that we can split it accordingly. So I'm going to take just that piece, which in this case is just that x plus 1, nice and straightforward. So I have x plus 1, and I want to know when is this thing positive, right, greater than 0. This is pretty much just about as nice as it can be, right? So I'm just going to move the 1 over. So I'm going to have x greater than negative 1, which means I don't have to do this part, but just to be clear, if I have negative 1, then when x is bigger than that, so when x is greater than negative 1 versus, right, when x is less than or equal to negative 1. So I'm going to convert, right? So I'm going to start by writing my full expression, right? The 13 minus 2, blah, 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 all of that, and then equals, and then I'm going to fill in the piecewise. So I have 13 minus 2 times absolute value, x plus 1 minus x. Okay. And I know, right, I'm going to split this, but I'm going to split it into the section that is greater than negative 1 versus less than or equal to negative 1. And I'm going to have the negative part, or I'm going to go from the left to the right as I go down. So I'm going to have x less than or equal to -1 versus -1 less than x, right? So I'm flipping those to make it look sort of nice, at least to my brain. Okay, so when I have that, maybe I'll do this side first, right? When x is greater than -1, which is this bottom line, that's when this doesn't do anything, right? So I have that is just 13 minus 2 parentheses now, x plus 1 minus x. And I don't have to worry about like making things positive or anything because it's already positive, right? That's what's happening when x is greater than -1. On the other side, though, this I do have to sort of be careful with. So here, again, I still have the 13. I still have minus and a 2. But then I need to multiply by -1, right? Because I'm going to make that thing positive, meaning that I have this x plus 1 bit. But because that would be negative when x is less than or equal to 1, I need the negative of that thing. Minus x. Great. So now I have successfully written this out, right? I've broken it up and it's in piecewise form, but now I want to simplify it, right? So for this part here, I'm going to sort of do this in 2 stages here. So I'm going to have 13. I'm going to have the -2 times the -1. So I have 13. -2 times -1 becomes plus 2. X plus 1 minus x. Whereas down here, I can distribute this -2 out, right? So I can do a -2 times that and -2 times that. So I'm going to have 13 minus 2x minus 2 minus x. And don't forget these things. So this is when x is less than or equal to -1. And when -1 is less than x. Okay. So now I can further simplify. So here I'm going to have 13 plus 2 times 1, so that's going to be 15. And then I have 2 times x minus x, so that's going to be 2x minus x is just plus x. Then down here, I have 13 minus 2, so that's 11. And then minus 2x minus x is minus 3x. And that is for x less than or equal to -1 and -1 less than x. Okay. Now I want to point out a couple things. So first of all, I want to point out that right, the left of -1, right, this section, the negative section where the x's are going to get big and negative, notice that my coefficient is positive, right? Whereas over here, when x is to the right of -1, so when it's big and positive, this coefficient is negative. And that's totally fine, right? Because when we're converting the absolute value, it's not about whether x is positive or negative. It's about whether what's inside the absolute value, whether that thing is positive or negative. And the other stuff outside, like this -2 times that might change the end result. So if the coefficients seem kind of like backwards in some sense, like they do here, that's not like a problem. You may want to make sure you didn't make any mistakes, but that's not a problem, right? That doesn't mean it's wrong. It just means that during the simplification process, stuff happened. The other thing I want to mention too is often we do, right, greater than or equal to 0 here, but when it equals 0, right, when the inside is 0, whether you take the negative of that or not, 0 is not positive or negative, so whether you multiply by -1 or don't, it's still 0. Where that equal sign doesn't matter, right, where it ends up. And we can tell because if we plug in -1 in both cases, right, if I plug in -1 here, I get 15 minus 1 is 14. 11 minus 3 times -1, that'd be 11 minus -3, which would be 11 plus 3. So I get 14 here, I get 14 there, same number. That's why it doesn't matter where the equal sign ends up. So again, like where that equal sign ends up usually doesn't matter because of that 0 issue. If you didn't get the same numbers here, then that definitely matters which one gets the equal sign, right? But because they're the same number, when I plug in -1 in either one, it ends up not mattering. Okay? So that is that.